Hello everyone. Today's our topic is substring search. Uh, we today we will talk about the three main algorithms, and this algorithm is used to search for substring, or you can say pattern in a string. It seems that it can be simpler. We move along the line and successfully compare the characters with the sample. But it didn't coincide. Move the beginning of comparison by one step by step and compare again. And for example, in this example, we can, for example, pattern is dog, yeah, and string is, you can see it's too long string. But in this example, it's easy to find the pattern by looking by the first look, and let's see the more harder example. For example, the pattern, as you see, the pattern is a b, and you can find the pattern in string just by looking, uh, and the function works as is quite fast if the samples and the string are good. The good ones are when the inner loop is interrupted quickly. For example, at steps like first, between, third. Let's say, like in the simple case in this slide, and but if the sample and the line contains frequently repeated nested pieces, for example, in harder example, and complicated case that above, and then the internal loop ends and near the end of the sample, and the search time is estimated as big O n times t. For example, if the line length, if the line length is 1000 maybe, yeah, and the sample length is 100, and by the formula big O and n times t, we will take 10 million. Of course, it's too big to run this algorithm. And for example, in everyday life we use Google, and in Google search we cannot use like this too long strings. That's why it's like it's not suitable for us. And let's look for more efficient algorithms than brute force. First is Knapp-Morris-Pratt algorithm. This KMP is like a small miracle. Why? Because highlight of KMP is a DFA. It's really small, and in implementation is short and so fast. And why miracle? Because he seems to be solving a completely different task, and this solution, after some wonderful trick, turns into a solution to the problem of finding all instances of the sample in a row. Now let's look in real life. Our string is A, B, A, C, A, B, B, C, A, and pattern is A, B, C. In KMP, first we should write the table. Table consists of letters which consist in the pattern, letters from pattern. In our case, A, B, C. We have A, we have B, we have, and as you see, it's our string, it's our pattern. Now we should write, we should use DFA and find this pattern in this string. First, we should first here we should write the letters which consist in pattern. For example, in our case is A, B and C. We wrote A, B, C here, and length of pattern. And for now we will draw the graph which identifies the steps, the next steps of. Now we will draw the graph which identifies the next steps. First, now the length of pattern 1 2 3 4 5, and here it shows the steps from, for example, from O cells to first cell goes letter A, and from first cell to second cell goes letter B, and like this by step by step, A, B, A, B, A, B, A, C. And now let's start our algorithm. First, from O cell to first cell, the letter A goes. We write here A 1 here, because from O cell to first A, others 0, and we save the X as 0. And in second column, we write the O's. In second row we write the first in first row we write the O's row. For example, 1 0 0 0 0. And now we will change in our graph from first cell to second cell. They're changing the letter B. Now we write 2 because we're changing B, and we look to previous X. X is 0, and B 0 is 0. We save X 0, and we look to table from second cell to third cell. They're changing the letter A. We write here A. Now 3, and the zero row is now we will fill the zeros row 0 0, and we look to the changing letter A, and the X is our X is 0. A0 is 1. We save X1, and from third to fourth is B. We are changing B. Here we write 4 and fill the row with the first row. Here is 1 0, and we look to changing letter is B. B1 is here 2. Now we save X as 2, and from third cell. From fourth cell to fifth cell, we are changing letter A. Now we write here 5, and we look to our X. X is 2. Second column, second row. Second row is third. We change it 5. Others 0 0. And our changing letter is A. A2 here is X. We save X as 3, and the last letter is C. Here we write 6, and look, X our X is 3, third row is 1 4, and we fill it all this table. And now we should by looking to table, we should draw the graph. First, from zero cell to itself goes letters B and C, and from zero cell to first is A. And the first cell from first to itself goes A here, 1 1 A, and other from first to second is B, and from first to 0 is C. And here from second to third is A. From second to third is A, and other from second to 0 cell is letters B and C. And here from third to fourth is B, and from third to first cell is A here, and from third to 0 is C. And from fourth to fifth cell A, as you see here, we draw before, and from fourth to 0 cell is here letters BC, and from fifth to sixth cell is the letter C, and from fifth to first cell is A, and from fifth to fourth is B. We finished our algorithm. Everything we have now, our table, our let's say our map. Let's check our algorithm. First, it's our string. Let's begin. A. We are going now. Here we are going A, and second letter is A, but we going inside of this cell like circle. We starting here A, and second letter is B. We are going to B here, and A, and here is C. We will return this C to the beginning of this map here. As you see, here is C, and we are starting A. We are going to inside A, and B here, A, B, A, C, and our let's say journey, our trip is ended, and by this way we know that if our map is ended, it means we found our pattern in string. Here is A, B, A, C. That's all. I want to show a DFA simulation of our example.
Now we are going to talk about one more interesting and efficient algorithm, which called Rabin-Karp algorithm. So let's begin. A basic idea of this algorithm is modular hashing. To understand what is this algorithm, let's start with pattern. We just take a sequence of pattern characters as a decimal number. So as you see, there is sequence of characters 2, 6, 5, 3, 5, and we take these numbers as one big 5-digit decimal number. So then we just take big any prime, not only 997. We can take any number, but it must be prime. So we take big prime number and take remainder number when you divide this decimal number by z prime. So we receive it as a result 613. So let's take this sequence of numbers as our text in which we search pattern. So Rabin-Karp algorithm, the idea of this is to take first 5 digits or 5 characters and take remainder by dividing this number to our big prime number that we used before, and compare answer is actually our hash. Compare this hash with pattern hash. So if they are matched, so we can consider that these five characters may be equal to pattern. So why 5? Because pattern length is 5. So this is that on which based Rabin-Karp algorithm. So it seems that we make a lot of operations or a lot of calculations, like cut 5 digits and then take module, but we have some linear time method to evaluate this to take this model. It based on that we change only first character and last character, and the middle ones are the same, so we can use it. Now we understand what is actually hash, and we need to improve this function, this hashing method or function. So this type of hashing is efficient if our pattern is length is so small, and all our characters are digits. We can just take first digit and multiply to 10 and next and so on, and we will take a 5-digit number. So if there is big long text, we cannot use it, and there is we have honors method. It based on that we take only first character, even if this is letter, and even if pattern length is long. We take just first character and take model of this and save it. And we also have R and the Q number. R is a base of integer. If we use a 10 based system, we need to use 10, and the Q is our prime number, big prime number. So as you see, it's very easy. As you see, honors method uses one for loop that is now so efficient, and then there is one question: how to efficiently compute these hashes, and then there is one theorem or one formula which says that because of we have many common digits, so we can create new hash with using previous hash. So how it's work? Let's look. We have what to create new next hash. We need to use current value of hash, that is actually this. Okay, and subtract leading digits that as you see, when we move to next, we lose first character. So and multiply to R which is 10, and add the new. You see, we there have new digit, and we need to add this. So as you see, there is the implementation of honors rule. So we have two versions of wrapping curve algorithm: Monte Carlo and Las Vegas versions. And so what is the difference? So as you see there, when we have match some hash in text with patterns hash, there is some chance that their characters may not be equal. So to make sure, you can check these characters by one for loop, and but it takes so much time. So but you cannot check this, and but the chance that your algorithm will return correct answer will be decreased. So Monte Carlo version always runs in linear time, extremely likely to return correct answer, but not always. So this version of wrapping curve and doesn't check the correctness, but the running time is decreased. So Las Vegas versions is always returns correct answer, because we check equalness one more time. So but we extremely likely to run in linear time. So, but we have some chance that algorithm will not work in linear time. So in worst case, m equals to n. That is not cool. So let's look to our problem.
And our last algorithm is Boyer-Moore. I think it's, in my opinion, it's the simplest algorithm in substring search. The main idea is they can scan characters in pattern from right to left and can skip as many as m text chars when finding one not in the pattern. Let's look for example. Here is our string and our pattern is needle. First, we should identify I and G. I is like starting point. J is length of our needle. But I may change the may change the value because they will skip every time they will skip in string. That's why in our example first our I is 0 and J is our length of needle is 5, and here we should compare with N and E. They're not equal. They will skip for we have a formula like J minus the value of the letter. Here our E, our letter value of E is here is 5, and by the formula J minus value of value of our letter 5, they will skip for 5 steps. They will repeat the algorithm S and E not equal. They will skip for here our I is 5, J is 10, and 10 minus 5, 10 minus 5 5. They will skip for 5 steps. Here they will start, they will skip it. Now they're comparing E is equal N and L not, and here our J is not 16 now 15. 15 minus N, value of N is here 0. J 16 minus 0, value of L, I'm sorry, 4. Our J is 6 minus 4 is for 2 steps. They will skip here. No. Yeah. Here is the comparing. Every letter is same. They finish the Boyer-Moore. What I want to say to you is you just know our I J, the main ideas of this algorithm. We should know I J and the skip. How many steps we should skip from here, and before starting the algorithm we should identify the like value of every letters. The letters that aren't in our pattern we just give -1, but the letters that
which is in our letter, we give by the order of these letters. Here D is in third place. We give values 3. E is in a first, second, fifth, and we give 5 value, and L4 in fourth place, like that. That's all.
So our problem is this. Your task is to find the pattern on the given text. If found, then it should print the amount of finding the pattern and the indexes. Otherwise, print -1. So let's look at sample tests. And there is one test. Look, if there is match with pattern, you should return the indexes. As used in first test, there is 11 matches, and we should return all indexes of this. If there is no match, you need to return -1. So let's solve it. So to solve this problem, we need to implement one of 3 algorithms that we passed, and I choose rubbing curve. So firstly, I created class, and I initialized variables. The first is string path, which is our pattern, and long pattern hash, which is our patterns hash. And M is length of pattern, Q is our peak prime, R is our system of digits, and Rm this is number that we use for removing leading digit. You will see. So I changed it as R to 256 for work and to work with letters, not only with numbers. And so I created hash function and our constructor. So there is pattern is and so it's M equals to pattern length, and the Q equals to 997. Okay. And then we found our pattern hash and RM. So as I said, RM is used for removing leading digit. So the hash function is Honor's used for Honor's. Our hash function uses Honor's method as we passed. So so I just write search function, and so let's look at this. So now we there have n, which is text length, and then because of our problem needs 1 minute. So in our problem we need to show our print all indexes. We need this array list. So and then so our search function also will return array list. If array list is empty, then we need to print -1, else we need to print oh sorry or else we need to print index in all indexes. Okay, let's look at this. And if length of text is less than length of pattern, then we need to return empty array list. Okay. Then we found our text hash. This hash is hash of only first m digits, m characters of text. So then we check if the pattern hash equals to text hash, and if they're equal, then we check we are using check function. So check function, we cannot use this check function if we use a Monte Carlos version. So there and there we can delete this, and it will be it will not be Las Vegas version, it will be Monte Carlos version. Okay. Sorry for my English. So we just add there will be one. We just add the one and the return ends. So if they are not equal, so we go on and starting with m, because we hashed our first m characters, and to the n we are using Horner's rule. By using Horner's rule, we are finding offset. Offset is index of match. So I think this is all clear, because it I teach you about 5-10 minutes ago. So let's look how it works. Okay, now we need to create our main function, and scanner. We need to initialize our writing cap. Then we need to write our pattern. Then we just call our search function. But because of its returns to us list, we need to create a list array list. Oh, sorry, wrapping cap. Oh, sorry, there must be public. Search our text. So now we can see if ands so let's look how it's work. Let's take one example, for example this, and the past. So we have same answer. So let's see this. What's the problem? I looked and there is our if statement checks only first two characters and returns to us our answer. So I think that we not need this. Or we can make like only first. So let's remove this and then so good. Okay, we found our problem and so this works. Let's check -1. For example, this -1. Okay. Thank you for watching, and so for my English and my coding. So I think that I was helpful for you. So